Greetings once again. Trigonometry for students and surveyors, lesson 19. We're back to our drawing that we had last two lessons. I want to start out by doing a little corrections. I made a correction in lesson number 17 on my YouTube website there. With this number is I inadvertently said that was my backsight that I calculated this angle from. The only reason that's there, that number there, I was trying to show, again, just kind of repeat, this is the backside azimuth, 283, 335.47. If you subtract 360 from that, then you get the backsight bearing. That's north 67 or 76, 64.53 in decimal format west. And then I proceeded to say that that's what I was backsighting to turn that. Well, no, it wasn't. I was backsighting 283, 350, 35.47. So apologize for that error. I did put a correction under lesson 17. I think I might have made a little bit of that a repeat mistake, but the math was all right. Just that was a blunder. So I apologize for that. But it does bring up a good point, a good lesson that we can all learn from that. I mentioned right from the beginning, your materials, graph paper, a scale, and a compass, and a protractor. If you're drawing all this stuff out and you're trying to be as accurate as you can, like for instance, this is every traverse point, and another thing I want to add, a traverse point and a control point are usually the same, but they're not always exactly the same. A traverse point is something you're usually going to set up on, turn your angles from. A control point can be the same thing, but a control point can be a point that you're not intending to set up on. It can be a check-in point or some kind of a monitoring point. It could be target cards on the side of the building, so they're not always exactly the same. A traverse point usually indicates you're going to sit on it with your instrument, backside another one, and turn angles and carry on. So to clarify that, another thing I talked about, the channel. When you go to the bottom, you do a measure down. Here I measured down with 24. I measured down with 18 from the center of the rim to the center of the channel. This whole long thing is a pipe. This isn't the channel. The channel only is formed into the bottom of a concrete structure. Usually these structures are usually 4 feet in diameter on the inside diameter, and they can be bigger, 6 or 8, whatever. So anyway, so that's what the channel is a half round, but it matches the invert of the pipes going in and going out. So the channel is only in the manholes. What connects the manholes is a pipe, usually a PVC pipe. All right, we have that. Another thing I didn't do was we calculated this, and I just had the numbers for you, and we created the coordinate here. I didn't really go in and tell you how we did that. Again, that's inversing from points. So we subtracted the northing from the northing. This is the northing and the easting of these two manholes. We subtract the northing and the northing and got 9.6703, that's a positive number. We subtracted the easting from the easting and got a negative 139.4414. So one thing you could get confused about, and we're also going to do the same thing back here, and I don't know if anybody else calls it the law of opposites, but I just did it for myself and for you to maybe help. If you're going from every time you're going east or going north, you're increasing your numbers. So remember I said you before, we started one of our traverses at 5,000, 5,000. Anything north of that, and the reason we start there instead of just 0, because if you go anywhere west of 0, you're just going to get into negative numbers, and anywhere south, you're going to get into negative numbers. So if you're going from a lower number to a higher number, if you're going to a positive direction, you're going to get a negative result. You're subtracting. So for instance, this is a northing 5361. We'll just use the first 4, 5351. So we know that we're going down. We're going down. So 90. If that was the same number as that would be a 90 degrees. So we're going down. So that's a positive. So a positive number is a negative direction. A negative number is a positive direction. We'll do enough of this, and I think if you go back to our other lessons when we did sine, cosine for each quadrant, you probably should have that in your background. This would be very, very easy here, much easier to understand. So the reason I'm saying that is because when you calculate a bearing or a new azimuth, you got to be able to figure out what quadrant you're in. If you're in this quadrant, the northeast quadrant, you leave it alone. If you're in the northwest quadrant, whatever you calculate for your arctangent, you got to subtract from 3, 6, or you just add. You add everything. You add here, you leave that alone, you add there, and you add here. You might be adding negative numbers, which is a subtraction, but that's okay. All right, we're just going to go into this. So we've subtracted the northing from the northing, got 9603. I've stored it under R. 7 and R are the same thing. And we have negative 139, the eastings, negative 139, 44, 14 is your easting. And see, we went east, we're going east, so it's a negative number because our number is higher, or gets higher, and we're subtracting a lower number from a higher number, so you're getting a negative in front of it. So you just always leave that. Now you want to departure. It's departure divided by the latitude. So our departure is Z. So we're going to go. Yeah. So you recall Z, recall the latitude, divide those, and we end up with 93. No, I think that might be the distance. Let me just do that real quick. Get confused here. So recall departure 3, 139, 441, recall divide. Okay, so we got 1, 4. Now we want the arctangent of that, and that's 860329, and I want to store that. Let me see if I've stored that. We'll go recall 0, 860329. So you want to store that arctangent. And now we have 860329. So that's our angle. So now we need to figure out what quadrant we're in, and that's how you do it. So we want to go 180 plus because we've gone past that. So we're down the lower hemisphere now. We're below that. So we want to add, we're adding a negative number, negative 860329. So 180 plus, and we get 939671. And I think that's our, yes, that's our, there it is, that's where that comes from. That's our azimuth from this, the center, based on the horizontal position. That's our azimuth from these two manholes. And then our distance, if you look at the survey books, they usually take quite a lengthy formula. They do the a squared plus b squared, c squared, and this is what you'd square out. So we'll go ahead and do that first, then we'll do it the way I like to do it, which is why I like to store the arctangent. So we're going to we'll recall r, square that, 93,514, then recall 139, 44, 14, square that, and then hit plus, or plus those together. 19,537.4187, the square root of that is 139,7763, and that's the distance now between these two manholes. That's using the square root. The other way is we have this stored, the northing, which is the latitude, stored. We have the easting, which is the departure, stored, and we've stored, there it is. I got too many numbers on here. I've stored our arctangent, which is 860329. So now you want to hit the sine of that. Let's hit with the cosine first. I usually use the cosine. Cosine of that, 1x, because that we're inversing it, and then recall the northing and hit times. 139,7763. 139,7763. So now we've checked it with a squared, b squared. We've checked it with the cosine of the angle. Now we're going to hit recall that arctangent again. Now we're going to hit sine and 1x that, which gives us 1.0024. And now we want to recall that difference there. We want to call our departure, which is 3, and recall 3 and times 139.7763. That's how we do that. Okay, we do the same thing here. Now we have that. We already had elevations. That's just a part that I skipped over last time. I just kind of had the numbers there. So that's how you do that. That's inversing 2 points. You get the bearing and you get the azimuth and the distance. Well, now we created a coordinate for this manhole, this new manhole, a design manhole 37 that they're going to have to put in. So we know where it's at, but we got to be able to sit here later on when they're ready for us to stake it and sit on this same control point, the same one we tied these out in, or any control point, doesn't matter, because they're all going to relate on the same basis of coordinates. So we're going to sit here, backsight this one. Now we have this manhole coordinate, and we have this traverse point coordinate. So we do the same thing. We subtract the northing from the northing, 46, 26, 26. We subtract the easting from the easting, and we get 5.3847. I don't think you can read that. 5.3847. 5.3847. All right. Now I think I've already stored those as latitude and departure, so we're going to go, let me just check. Recall L. Oh. Recall L. 462626. Recall D. 53847. Okay, it's departure over latitude, so we'll go divide that now. I'm going to bring that back in. Recall L. Divide, and we get 0.1164. Now we want the arctangent of that. And I have that stored somewhere. There it is. 6.639. I have that stored as T. I already pre-did this, so let's just see. Recall T. Okay, we have that. We have the arctangent of that. So that is, again, now we are a negative easting. So that means we've gone a positive, or we've got a negative departure. Oh no, what do I have here? So we've got recall T is 6. So that's a positive number. So it's going in a negative direction. All right, the law of opposites. So it's going in a negative direction. So now we take 180, we're going to the southern hemisphere. Now we take 180 and plus that. 186.6390. And so our azimuth is 186.6390 from this trap point to where the manhole is going to be. So that's what we need there. And now to sit on this, we're going to backsight that one. Our backsight azimuth is 4191.25, and that's an azimuth. That's not a bearing, that's an azimuth. So we take 4191.25, enter that in there. Now this was our angle. It's this black one here, and that angle, the way you get the angle, well, let's just go to that 4191.25, and our azimuth is 186.6390. We'll go minus that. So we have an angle of 144.7265. That's our angle. So if we put our protractor, anyway, if we put our protractor here and zeroed it there, 144 is there. Although the true north, that's still north, but you see that's not north, that's backsight 41 degrees. So you'd add that to it. So now that's how so now the gun knows that's how the gun works. You set it in there, you say you're backsighting this. This is your new azimuth. To get that, you have to turn this angle here, which is 144.7265. Okay, so that's it. We have our angle. Now, if you were going to do a 10-foot offset or a 12 offset, you would add that, you just punch that into your data collector and it would change that azimuth a little bit to compensate for that. Same with a 15-foot or a 20-foot lineup. They do it really fast. We could figure this all out with the calculators, but that's the beauty of a data collector. It does that, boom, right away. So let's go, now we just need a distance, and our distance is going to be, we could go a squared, b squared. So let's try that first. We'll go recall L, square that. We'll go recall D and square that, plus and the square root of that. 46, 57, 49, that's the distance. And then of course the other way to do that is, that's the distance. We want to recall our tangent. Did we store that? Yes, I stored the arc tangent as T. We want to recall T, 663, 9. Then we want to go cosine and 1x. Then we want to recall L, which is our northing, which is our departure, and times 46, 57, 49. Okay, one more time. We're going to recall the arc tangent, which is, on mine is T. And we want to sine, to get the sine of that, 1x, we're inverting it. And then we want to recall the departure, I guess that's D, and times 46, 57, 49. Boom. And we're there. So now we have that. All that would be stored in there. If you were to come out here and they said stake the center, pull in your offsets, whatever you set there, backsight that, turn that angle, go out that distance, that's where the center of the new manhole is. And I think that's what we're going to call that for lesson 19. Now I know I said I was going to go into notes. I'll probably get this published first and go into, erase it all and go into notes on lesson number 20, and we'll see what else we do. So thank you. Hope you're getting something out of this. Please like and subscribe and pass this around to anybody you think might get any benefit out of basic trigonometry and practical trigonometry for students and surveyors. Thank you.